The 1950s were a golden age of the Canadian aerospace industry. Designers and engineers at the Avro Canada Company stand out from the rest. They were responsible for the sleek lines of the now iconic Aero, a plane whose glow outshines nearly all others. However, they produced another plane, a jet fighter like the Aero, a great plane nearly forgotten in our collective consciousness. The CF-100 Canuck. In its day, it was a competitive all-weather interceptor. The Canuck protected Canadian airspace from the threat of nuclear-armed Soviet bombers for over a decade. As Canada's only indigenously designed jet fighter to reach service and to be built directly to RCAF specifications, it was an accomplishment that would give Canadian industry the confidence it needed to eventually undertake the Aero and to secure its place as a world aerospace power. The story of the Canuck started in 1946. The Royal Canadian Air Force issued a requirement for a long-range all-weather interceptor to meet the threat posed by the Soviet Air Force. It was specified that the fighter be capable of mounting an advanced radar and fire control system enabling zero visibility interception along with competitive speed, rate of climb, and altitude performance. The RCAF also specified that the new fighter have 2 engines. This redundancy was seen as necessary given the Arctic patrol missions the aircraft was expected to carry out. The Avro Canada Company, based out of Toronto, Ontario, met the challenge and produced the first prototype aircraft called the Avro XC-100 in late 1949. At that time, the RCAF was equipped with its first jet aircraft, the British-built de Havilland Vampire. But the Vampire lacked the necessary performance and was quickly superseded by more advanced types like the Canadian-built variants of the F-86 Sabre. Although competitive in its own right, the Canuck was only envisioned as a stopgap measure to fulfill an all-weather air defense role until a more advanced aircraft could be built. Originally, that aircraft was meant to be the ill-fated Aero. The company unveiled their cutting-edge new aircraft, renamed the CF-100 Mark I, and it was ready to fly in early 1950. The successful first flight of the new fighter was on January 19, 1950, powered by 2 British-built Rolls-Royce Avon RA3 turbojets. Subsequent pre-production aircraft, called CF-100 Mark IIs, were powered by the Canadian-built Orenda 2 axial flow gas turbine turbojets designed by Orenda Engines, a subsidiary of Avro Canada. All future CF-100s were powered by evolutions of these engines, culminating in the Orenda 14 series fitted to later model Canucks. It featured a respectable thrust for its time of 32 kilonewtons at sea level. The Canuck was equipped with a pair of Martin Baker Mark II CFE or Mark III CFE ejection seats. These seats provided pilots and radar operators with a safety margin that extended from low-speed, low-altitude to high-speed, high-altitude ejections. Although development of the Canuck was initially successful, problems were encountered with the pre-production aircraft. 2 of the 10 aircraft crashed, resulting in the deaths of a pilot and an observer. While the crashes were determined to have been caused by pilot error, technicians noticed wrinkles in the center sections and cracks developing in the spar web of the test aircraft. This caused significant delays as the airframe was redesigned and reinforced. The CF-100 Mark III was the first production version of the aircraft, with deliveries starting in the spring of 1952. It was a refinement of the Mark II Canuck and featured a strengthened airframe and new avionics. The Mark IIIs were equipped with 2 Orenda 8 turbojets, each producing 28 kilonewtons of thrust. It had a wingspan of 15.8 meters, a length of 15.9 meters, and a height of 4.4 meters. Its maximum service ceiling was 13,000 meters or 45,500 feet, and could reach speeds in excess of 1,000 kilometers per hour, or Mach 0.85. The Canuck was fitted with a Hughes Aircraft APG-33 X-band fire control radar in the nose, and 8 powerful 50 caliber Browning M3 machine guns fitted in a ventral pod below the pilots. The job of rearming and aligning the 8 electro-pneumatically operated guns was made easier because the units were interchangeable. Spent pods could be quickly swapped out with fresh ones, thus decreasing their mission turnaround time. The rate of fire was good at 9,600 rounds per minute. However, the Canuck's ammunition supply would run out after just 12 seconds. A total of 66 aircraft were produced. The first 21 were equipped with the same Arenda 2 engines as the Mark IIs, while the rest received the uprated Arenda 8s. These early Canucks went into equipping the first 3 tactical fighter squadrons. All remaining Mark IIIs were sent to operational training units to teach pilots to fly the more advanced Mark IV and Mark V models, or converted to dual-control trainers after their withdrawal from frontline service. A few also went into special projects, such as the development of the Velvet Glove missile, and measures to increase reaction times in the case of a surprise attack. The RCAF began experimenting with JATO rocket boosters to shorten takeoff distances, but this system didn't see active service. The Mark IIs and Mark IIIs can be distinguished by the pointed nose cone and 2-piece canopies not found on later models. Attempts were made to improve the overall design of the Canuck. A transonic wing concept called the CF-103 was offered up in 1951. A mock-up was created but later dismantled completely when it was found that the CF-100 was indeed already transonic in a dive. On December 18, 1952, the Avro Company chief test pilot took a CF-100 Mark IV prototype past Mach 1 in a dive from 9,100 meters. The Canuck became the first straight-winged aircraft to accomplish this feat. The CF-100 would have only had marginally better performance, and so the entire project was cancelled. The CF-100 Mark IV was a further refinement of the Canuck series in terms of firepower and performance. It began coming off the production line in the fall of 1953. This new version was fitted with the more powerful Hughes Aircraft APG-40 fire control radar. The fire control system was connected to 2 wingtip pods, each containing 29 folding fin aerial rockets, in addition to the 8 ventral machine guns. The more lethal unguided rockets were an attempt to overcome the perceived inadequacy of the gun in downing large bombers. The Canuck was designed to be rearmed and refueled quickly for fast mission turnaround. The interchangeable wingtip rocket pods and ventral gun pods could be replaced and realigned quickly using a guiding pin system. The fire control radar allowed pilots and navigators to establish collision course interception for their guns or rockets in all weather conditions. The backseat radar observer would use the 250 kilowatt radar to locate the target, and to supply the fire control computer with the necessary information to provide course and timing indicators to the pilot. One scope for the radar operator was used to select a target. The pilot would then be shown a vectored target and time to fire circle on a second scope. The pilot would maneuver the aircraft and hold the trigger. When everything was lined up, the system automatically fires the rockets and the pilot banks away. Initially, all the rockets would be launched in one salvo. Later versions could launch partial salvos, allowing pilots to make a second pass at the target if needed, or to attack multiple targets. radar set could also be used for all-weather navigation. It could be set to lock onto ground station beacons, or set to use a terrain mapping function as required. The CF-100 had 4 external mounting points for weapon stores, including the possibility of mounting 4 1,000-pound bombs. This gave the Canuck a ground attack capability, although the aiming system was primitive. Early Mark IVs came equipped with the improved Orenda 9 engine. These engines provided 29 kilonewtons of thrust each and helped to make up for the added weight of the new systems. A total of 137 Mark IVAs were built, including upgrading 54 Mark III airframes that were already in production. Later, the Mark IVBs were equipped with the even more powerful Orenda 11 engines. These provided a further increase to 33 kilonewtons each at sea level. 141 Mark IVBs would be built over a period of 2 years. They were introduced into frontline service starting in 1954. Operational Canucks were expected to perform in all types of conditions, ranging from sweltering summer heat to frozen Arctic winters. Canucks needed to quickly climb to high altitude and engage increasingly sophisticated Soviet bombers with rockets on short notice. To this end, the design of the CF-100 wing was changed in the Mark V to improve its high-altitude performance. Its wings were lengthened from 15.8 to 17.4 meters. The tail wing was also redesigned and lengthened. The guns were replaced by another rocket pod, although this feature was also found on later model Mark IVs. The engines were again improved, and the later Mark Vs would receive the Orenda 14, considered to be the best in the series. This same engine also went into powering later model Sabres. These changes increased the service ceiling of the Canuck to over 13,500 meters. This variant proved to be the definitive version, and production of the Mark V was steady. In all, 332 Mark Vs would be produced starting in 1955. This variant of the Canuck relied entirely on the unguided rocket system. The effectiveness of these unguided rockets was called into question, and so guided alternatives were explored starting back in 1951. The Canadian government initiated an indigenous guided missile design called the Velvet Glove. It incorporated semi-active radar guidance with a range out to around 8.4 kilometers. Starting in 1954, over 300 tests of the Velvet Glove were conducted using modified Mark V M Canucks. Although the program showed some success, it was overly complex and lacked sufficient range to be effective. The missile program was eventually cancelled in 1958 along with the proposed Mark VI Canuck. It featured improved engines and a redesigned tail. Canadian scientists also worked in collaboration with the Americans on their Sparrow 2 project in the event that their own would prove ineffective. Later, the Americans would cancel this program, believing that the technology, like the Velvet Glove, was too complicated for its time. This left the RCAF without a guided missile option until the arrival of the Falcon series of missiles with the CF-101 Voodoos in 1961. In the 1950s, the threat that Russian bombers carrying nuclear weapons could come across the Arctic Ocean to attack North America was a very real and immediate danger. As a response, the air defense role of the military was given special attention, and what would later become NORAD was initiated in 1956. The Canadian contribution included fielding 10 frontline home defense squadrons at its peak to guard the northern approaches. The contribution also involved hosting a series of early warning radar stations positioned across the country. They were the Pine Tree Line, Mid-Canada Line, and the Distant Early Warning Line, or DEW Line. Once enemy bombers were detected, air assets could then be vectored to intercept the long-range Soviet intruders such as the Tupolev Tu-4 Bull, Tu-85 Barrage, and Tu-95 Bear. The day fighting component was covered by 5 squadrons of Canadair Sabres. They were based near population centers spread across the country. Day fighting in this case refers to visual aerial combat. To fight in zero visibility conditions, the RCAF began introducing CF-100s into frontline service starting in 1953. The first to receive the new fighters was the 445 Wolverine Squadron, followed by the 423 Eagle, 440 Bat, and the 419 Moose Squadrons, all equipped with the Mark III variants. To prepare pilots for the more advanced Mark IV and Mark V models, the No. 3 All-Weather Fighter Operational Training Unit, or Night Witches, was formed at CFB North Bay. The program was later moved to CFB Cold Lake, where they flew Mark IIIs modified to dual-control trainers, as well as some Mark IV and Mark V models. Next to receive the Canuck was the 428 Ghost Squadron, followed by the 425 Alouette, 432 Black, 409 Nighthawk, and the 433 Porcupine Squadrons equipped with Mark IVs fresh off the production line. Finally, the 410 Cougar and 414 Black Knight Squadrons were formed equipped with the Mark V. It should be noted, however, that by this time the other frontline squadrons had also re-equipped with Mark IV and Mark V models as they had become available. In addition to their commitment to NORAD, the RCAF also played a significant role in the air defense of Europe. In the early 1950s, the Canadian government committed itself to fielding the 1st Canadian Air Division, which originally consisted of 12 squadrons of Canadair CL-13 Sabre fighter aircraft to counter the threat of a Soviet invasion. While competitive dogfighters, the Sabres were visual day fighters, and the need for an all-weather night fighter was identified by NATO. As a result, 4 of the 12 Sabre squadrons stationed in Europe were replaced by 4 squadrons of CF-100 Mark IVs. From 1956 to 1957, the 445, 423, 440, and 419 squadrons were ferried over to European bases through Operation Nimblebat, where they served with NATO units until their withdrawal from frontline service there in 1962. For most of that time, the CF-100 had the distinction of being the only NATO aircraft capable of interception in zero visibility conditions, such as bad weather or at night. Canucks serving with the 1st Canadian Air Division can be distinguished by the camouflage paint scheme not found on the unpainted home defense fighters. The NATO role of the 1st Canadian Air Division changed in 1962 to a tactical nuclear strike and reconnaissance mission. This resulted in the withdrawal of all Canadian CF-100 squadrons from service in Europe. The 8 remaining squadrons of Sabres were re-equipped with the CF-104 Starfighter. 1962 also saw the 9 remaining CF-100 frontline interceptor squadrons guarding Canadian airspace replaced by 5 squadrons of the American-built F-101B Voodoo interceptors. These fighters brought a significant capability increase to the RCAF, although they did not meet the specifications set out by the more advanced Aero project. The oldest serving CF-100s were with the 414 Squadron based in North Bay, Ontario. These CF-100s were upgraded to the CF-100 Mark V-D standard, where they remained in the reconnaissance, electronic warfare, and training roles until 1981. The only foreign sales of the aircraft were to Belgium. They bought the CF-100 Mark V in 1957, and over the next 2 years, 53 aircraft were delivered. These fighters served in 3 squadrons of the Belgian Air Force until 1964, when they were replaced by F-104G starfighters. In the end, a total of 692 CF-100s were produced to field a total of 13 squadrons. Tragically, 16% of these, or 110 Canucks, were lost to accidents, resulting in the deaths of approximately 100 crew members. The most notable of these accidents is known as the Covenant disaster, in which a Canuck flying out of RCAF Uplands crashed into a building belonging to the Grey Nuns in Orleans, Ontario. The tragic crash resulted in the deaths of 13 people on the ground and both aircrew. The Canuck would be the first and the last Canadian fighter to reach service with the RCAF. Since the cancellation of the Aero project, procurement of military hardware has had to look outside our borders to fulfill its fighter requirements.